fellow mathematicians. Welcome to the podcast where math is figure-outable. I'm Pam.
And I'm Kim.
And we make the case that mathematizing is not about mimicking steps or rote memorizing facts, but it's about thinking and reasoning, about creating and using mental relationships. That math class can be less like it has been for so many of us and more like mathematicians working together. We take the strong stance that not only are algorithms not particularly helpful in teaching, but that mimicking algorithms actually keeps students from being the mathematicians they can be. We answer the question, if not algorithms and step-by-step procedures, then what?
So in the last two episodes, we began the conversation around models and modeling, right? And how it's important to consider the progression of modeling. First, the model of the situation, then the model of student thinking, and then using that model as a tool.
And in this progression of modeling, notice that it's not about any model. It's about models that can become tools, important tools. So in this episode, we're going to get specific about a couple of recently popular models that we think should be de-emphasized and what we can do instead. So y'all, I often get asked about what I think about number bonds and tape diagrams, or sometimes called strip diagrams, and how they play out in some current textbooks. People wonder about that. People are really curious about how they fit. I think people might be noticing that we don't use those two models at all.
At all. So Pam, let's start with number bonds. What is
All
a
right.
number bond, and will you describe a number bond for the listeners?
Okay, so I think a number bond is a well-intentioned idea of helping kids focus on the relationships at hand, focus on what's sort of happening in the problem. And so it looks like this. Often it looks like circles, and those circles, there's two circles that are sort of the parts, and those circles are kind of connected to this larger, the whole. And so there's like a big circle that's the whole and two circles that are the parts. And so, yeah, like explaining this over podcast is trippy. So like,
Right.
Kim, pick a number.
65.
Okay, so a number bond for 65 could be, I put 65 in sort of the total place, and then I kind of draw two lines that come off of that circle, and I draw two smaller circles, and I could say 60 in one and 5 in the other. Or I could do a different number bond where I could have 65 as the total, and I could have 50 in one and 15 in the other. Or I could even have one where I have 65 in the total, and I could have 70 in one and 5 in the other, because I'm sort of 70 minus 5 is 65, and then I might have to play around with which one's bigger and all the things. Okay, so it's like sort of like, how are these numbers related to each other? All right, so let's also talk about the other ones. We talked about number bonds. That's what they look like. Kim, what's a tape diagram or strip diagram?
Yeah. So a tape diagram is a rectangular box, maybe with a couple of empty spaces where students would take numbers from a problem that they're given, and they are supposed to put the numbers in the correct spot. So, like if it was a missing add-in problem, they might fill in one part and the total, the numbers from the problem, and then they need to find the other part. It's a way to organize information from the problem.
Yeah, exactly. So I might have the total kind of outside the rectangle. I've seen where I might have one rectangle, and like you just said, the parts are inside and the
hmm
total's kind of outside the rectangle.
hmm
I've also seen it where the total is its own rectangle, and then the parts are kind of a rectangle below that, cut in pieces, and you sort of put the parts in that second rectangle that is the same size as the total. Okay, so let's talk about how those two models are, in a way, a model of the situation. So we've talked about our modeling context that we like, where kind of the beginning step is a model of the situation.
hmm
And so, in a big way, we feel like number bonds and strip diagrams are models of the situation. They
hmm
are an attempt to get the relationships out there, to make them visible. So, which one's the part, which one's the whole? Oh, do you have two parts and you need to find the whole? And so, both of those models could sort of help kind of get that understood. If you think about a problem solving step-by-step procedure, which we don't advocate. But often that first thing is understand the problem,
Yep.
right?
Yep.
It's like important. And why is that the first thing? Well, because it's important to understand the problem, or you're probably not
Sure.
going to solve it correctly. So of course we need to understand the problem. And so this is my number bonds and strip diagrams are a well-intentioned attempt to say to kids, understand the problem. Where it can go awry is when we demand that kids draw it every time. If I'm a kid who already understands what's happening in the problem, I don't think it's very helpful to demand that I draw the number bond or the strip diagram. It's just like an extra step that it doesn't help me. It's not if I understand it. If I'm the kid who doesn't understand what's going on in the problem, it might help to draw the number diagram or the strip diagram, the number bond or the strip diagram. It might help to do that, but often it also becomes like sort of this extra thing to do that it's like, how big do I draw the rectangle, and does it need to be tall or and kids like pay attention to all this weird stuff that doesn't even
Yep.
have anything to do with the problem itself. So
Yep.
it kind of becomes like this extraneous thing that may or may not be helpful. So do we want kids to understand what's happening? Absolutely. So also another thing that can kind of get in the way. So think CGI. Have we done a podcast episode on CGI
Oh
and
gosh,
where we
we surely we've mentioned it at some point.
if we haven't, we'll do one soon. But if you're not familiar with cognitively guided instruction, we really appreciate cognitively guided instruction, which is referred to as CGI, because they did a lot of really groundbreaking research that then has allowed us to build on that research. But sometimes we get a little, we might have the opportunity to get a little bit mixed up here. In CGI, there's a strategy called direct modeling. Direct modeling is all about acting out what's actually happening in the problem. A good thing, right? Another well-meaning, like, let's model what's going on in the problem. That can be a very necessary thing for kids to do when they are beginning problem solvers. I need to like actually act out what's happening, and then I use that acting out to help me solve the problem. But that can be different than a model of the situation, because it can be, how do I say this? Direct modeling is where you're actually like acting out the problem, what's actually happening in the problem. Strip diagrams and number bonds are less of acting out the problem and more of the of a model of the relationships at hand, or model of the relationships that are happening in the problem. But what's interesting is all of those are a model of the situation in our framework. Whether I'm acting out the problem to understand it and to solve it, maybe just say to understand it, whether I'm acting it out, I'm direct modeling, or I'm drawing a number bond, a strip diagram as getting the relationships out, what's happening in the problem, we would consider all of that the model of the situation. That's
Right.
sort of the beginning of our kind of modeling scenario here, or
Yep.
our the way that we think about modeling. So it might be true that a student needs to act out the problem, directly model the problem with actions or drawing what's actually happening. And that's fine. And we would call that a model of the situation. But we can also be more abstract in general, like the number bond and strip or tape diagram, where it's more of a graphic of the relationships involved. It's less the action that's happening. Either way, these models of the situation set up the relationships.
Right.
What they don't do is represent what you're actually doing to solve the problem, how you're actually using the relationships to compute.
Yeah.
So let me get a little bit more specific. I know I'm doing a lot of like not very example discussion here. So let's get examples. Let's get to some examples. So what's an example of a number bond and how it can be helpful? And maybe less helpful than we might have been led to believe. So here's a problem. Let's say, hey, we're reading. We like to read. Kim and I both read. Woo, reading's good. We're on page 195 of the book, and there are 303 pages in the book. Hey, how much do we have left to read? That could be a great problem, right? So, there's the problem. We need kids first to understand the problem. We don't want kids flipping a coin and just grabbing the numbers 195, 303, and like adding them or multiplying them or dividing. We don't want that to
Sure.
happen. We want them to actually understand what's happening. So, kids could draw a number bond or a tape diagram with let's a number bond first. They could put 195 in one little circle and 303 in the 303 in the total circle, and then a blank in the other sort of part circle, the other smaller circle. Like that. That's how they could sort of like, okay, I know what's happening. I've got 303 in the total. That 303 is the total number of pages, and I'm at 195, so that's part, and then I have this other part, the pages I have left to read. I could also do that on a tape diagram. I could have the whole rectangle be 303, and then I could have that second rectangle where I've cut it and I've put a 195 in part of it, and I need to find the other part of that second rectangle, the empty part to find. But now what? We've
Yeah.
represented the situation, the scenario, we've got it. We understand what's happening. But now how do we find that missing part? Okay, so Kim, how might a kid solve that problem?
Right. And here's the important part, right? So if I'm thinking about 303 minus 195, I might say 303 minus 200 and get 103. And then I've subtracted too much, so I can add back that 5 to get 108.
Bam! And you used a nice over strategy. You
Right.
thought about that problem as subtraction and you subtracted a bit too much and then you added back. Nice, super. That's the strategy. That's we're focusing on how students are solving that problem. And that was a very nice, sophisticated strategy. Super. So now, as a teacher, in our sort of way that we think about modeling, now it's the time for our second thing where I would take what Kim just did and I would model that. I would make it visible. I would draw an open number line and I would start at 303 and I would draw this big jump back of 200 and I would say, where'd you land again? Land on 103. And then I would say, Kim, what'd you do again? Or depending on how much I'm working with the student. And she says, well, I subtracted too much. And so I'm like, how much too much? She said 5 too much. So then I would draw back. The jump shouldn't have been as long. So I would back up 5. And then, okay, so what is that? 103. And then up that 5. So now we're at 108. And I would draw that 108. And I would go, hey, does this represent what you just did? Check it out. The relationships you just used, now they are visible. We can use this open number line to make that visible. Cool. Then over time, I can ask that kid, hey, you've seen me represent your thinking. You've seen me do that a few times. Now, the next time you do that over strategy, I want you to represent your thinking. Now, you make your thinking
Yeah.
visible, just like we've done. Cool. Then over time, and with lots of experience, that model becomes a tool, and kids might actually use that model to solve that problem. That's our hope. That's our modeling sequence. Okay, so Kim, what if a kid had used a different strategy? Same problem.
Sure. So a couple of other strategies, right? So here's one. What if I found the difference between 195 and 303? So that might look like the teacher drawing a number line. So let me describe what I would do first. So if I had
Okay.
195, then I could add 5 to get to 200. And then I could just add 103 to get to the 303. So add 5 to 200, and then add 103 to get to 303. And then that would look like a teacher drawing the number line with the 195 on one end and the 303 on the other end, and making those hops that I just described kind of on top of the number line to show the plus 5 and the plus 103, which is the total of 108.
Excellent. And you would write all that out. The
Yeah.
teacher would model that student's thinking, represent that student's thinking. Sometimes people call it annotating students' thinking.
Yeah.
I don't really like that so much. Maybe we'll bring that up in a minute. I like representing the student's thinking, using that number line because we know that's an important, powerful tool. But you said a couple strategies. All right, give me another one.
Well, how about you give me one? I just gave you two.
Okay. So if I'm thinking about 195 and 303 and the
Uh-huh.
distance between them, I might choose to find that somewhere slightly different. I might put them both on the number line and nudge them up both 5. So
Oh,
now I'm
okay.
finding the distance or difference between 200 and 308 because
Nice.
I've moved both of them up 5 because 308 minus 200, bam, is just
Nice.
108 and I'm
Yeah.
just there and I'm sort of done. And we call that the constant difference strategy.
Yeah.
So, as we just talked about this kind of sequence of modeling, I have gotten to the point now where when I solve subtraction problems, I think on an open number line.
Yep.
It has become a tool for reasoning for me. But funny, are you ready? When I just did that, if you guys could have seen me, I literally had my hands in the air and I put one hand where I could see 195 and I put another hand where I could see 303,
Mhm.
303, and I moved them both to the right, up 5.
Yep.
so that I could see that 200 and see that 308, and then I could solve the problem. Now,
Yeah.
it took me way longer to discuss what I did than
Yes.
it did for me to just, I just like my hands were in the air and I went, and it took me way shorter to solve that problem, way more efficient to solve that problem than it would have. Can you imagine the traditional algorithm for 303 minus 195? Wow, all those opportunities for error.
Lots of crossy Abbies.
So lots of crossy Hatties. Again, over time and with lots of experience, that model becomes a tool, and then kids and me actually use it to solve problems. Notice that the model that we're advocating is an open number line. That is a tool worth building.
It is. And I'm going to go back for a second because I think you mentioned something that we kind of glossed over. And the really, really important thing that I think you just said was that over time you ask a kid, hey, when your brain does that, it can look like this. Does this match what your brain did? Right? Because we want to
Mm,
represent their thinking. So we just talked about a model that we love for subtraction and really addition too, and that's the open number line.
hmm
But for multiplication, division, and proportional reasoning problems, Pam, what's your preferred model?
Yeah, that's a really good question because we started talking about strip diagrams and tape diagrams, and
Yeah.
that's often where we see tape and strip diagrams. We see those. I'm saying them like they're two different things. They're just called those. So maybe I should choose one. Strip diagrams. We see those often in proportional reasoning problems where we sort of set up what's happening in the proportion, and then we can kind of think about the relationship and those ratios, and then we can kind of solve them. But how do we solve them? That's the rub, right? Like it's just the setup. It's just a strip diagram only helps me get a feel for what's happening. It doesn't then help me use the numbers and the structure to
Right.
solve the problem. It definitely doesn't model what I do to solve the problem. It just sort of sets up the scenario, the situation. So in episode 58, we actually walked through kind of a way that we use ratio tables. We use our modeling paradigm to think about setting up a ratio table. And I use sticks of gum. So if I have sticks of gum in a pack, then I can think about how I can model that situation by I start putting down in a table. Okay, I've got one pack to 17 sticks, and I've got two packs to how many sticks. And as kids say those numbers, I put them in the table, and it's a model of the situation. And then as they solve problems, I model their thinking. I represent their thinking using scaling or using lines to sort of, I'm adding packs together. So I add the sticks together, or I'm scaling as I double the packs, or as I multiply the packs times 10, then I multiply the sticks times 10, and I represent all that thinking on the ratio table. That's the model of thinking. And the more that we do that, and through time and experience, that tool becomes a model for thinking. Well, I can do the same kind of a thing with a non-unit rate scenario. So if I have something like 4 slices of pizza for $5, I represent that scenario. First, it's a model of the scenario, of the context, where I put 4 slices of pizza for $5. And then as students think about different numbers of slices and their cost, or different amounts of money and the number of slices of pizza I get, as they solve those problems, I represent their thinking using that ratio table. And our goal is then to transition to where that ratio table becomes a tool for thinking in order to think. And now students, when they see a proportion, they think to themselves, "Oh, well, how does that fit in a ratio table? And now how do I use? I can use that ratio table as a tool for thinking."
So, in a nutshell, these other models that we've been talking about are not bad or wrong. They're just really limited. They can help students slow down and evaluate what's happening. It's just a format, though, and in any case, it doesn't help you decide what to do with the numbers, like you said. But teachers think it does. It's like manipulatives,
Yeah.
where we think the math is embodied in the manipulative, but that's only because we've already schematized it, not because we can now just show what we worked out and have it magically transfer to our students.
Oh, it's
Teachers,
so well said.
yeah,
Magically
teachers,
transfer. Yeah.
teachers have probably seen this a ton, right? This is
hmm
you might have seen a student who may or may not be able to take the numbers from a word problem and figure out where to place them in a tape diagram. Maybe they can do that. But even if they're able to, many of them get stuck in knowing how they want to mess with the numbers.
Yeah, even if they get to that point, now they're there.
Yeah.
And what do we do next? And what we haven't done is help teachers know what to do next. Well, voila, we are helping you hopefully know what to do next. You ask lots of good problems, pull out that thinking of kids. You represent their thinking using a very important model that then can become a tool for them to solve problems. with. So it's helpful to figure out what's in a problem. Okay, okay. You can do it in other ways, but tape diagrams, number bonds, fine way. It's fine. But don't get caught in demanding that from students because number bonds and tape diagrams are not particularly helpful to know how to mess with the numbers after that. And they're also not the models that we believe will become the tools we want students to become really familiar with so that they can use them as tools for thinking and reasoning and mathematizing. All right. So, if you want to learn more mathematics and refine your math teaching so that you and students are mathematizing more and more, then join the Math is Figure Outable movement and help us spread the word that math is figure outable.